all right, if this is the origin and you are moving -1, that's left 1, and you are moving up 2, that's up 2, bringing you to what? Somebody said something. What?
5e.
Yeah, E5, 5e.
I played chess before. I was questioning how it was going to move.
Well, a knight's allowed to move that way. So shame on you for questioning whoever that was.
No, because it can move 1, 2, 3, 4, 5, 6, 7, 8. 8 different ways. I didn't know which way.
I'm sorry. Bingo. Very good, Keon. Joke of the day goes to Keon. What are we doing? Well, the Velociraptor says that we are doing point line plane. This is literally the first geometry section that you're ever going to see. Hooray! We are now in geometry. We are now moving from a lot of math to a lot of pictures. So let's try to understand this vocabulary. We have a point, okay, which is literally, if I were to take a marker, any marker will do, but if I were to take this here Sharpie and go to something and go, boop, that's a point. We label a point with a letter. In this case, the letter A represents the point A. It is 0-dimensional. Okay. Now, when we call things 1-dimensional, 2-dimensional, 3D, when you go see a 3D movie, it's called 3D because it has 3 dimensions. Up, down is a dimension, left, right is a dimension, and then forward, back is a dimension. So what makes a normal 2D movie, 2D is 2D because it's up, down, left, right, and so you have like a flat surface going on. What makes it 3D is the fact that you could put these magic glasses on and the spooky ghost pops out at you. That's what makes it 3D. A point is 0 dimensions. It's 0 dimensions because it doesn't go up left. It doesn't go, or not up left, but up down or left right or out in. It's just there. It's a dot. 0 dimensions. A point is 0 dimensions. A line is 1 dimension because it goes either left, right, or up, down. Diagonal falls into that as well. So it's made up of points and has no thickness or width. There's exactly 1 line through any points. Now, if I were to name a point, it just has a letter attached to it. If I were to name a line, you could take any points on the line and name that line. For example, I see that line over here. It has 2 points on it, P and Q. I can call that line PQ. I can call it QP. It doesn't matter. I can call it line M as it says over here. Either way, I'm talking about the same line. See those arrows? Those arrows indicate that it goes on forever. A line is a straight object that goes on forever in both directions. If I were to add another dot right there and call that dot, I don't know, S for Santiago. If I were to call that dot S, I could call that line PS or line SP or line QS or line SQ. I can name that line several different things. Usually, when we name a line, we put the symbol for a line above the name of that line. If it doesn't have that symbol, it usually indicates distance. So for me, if I'm naming a line, I'm always going to draw that little line at the very top. Okay, so far we have 2 things. We have a dot, which is a point, 0 dimensions, and we have a line, which is left, right, or up, down, or diagonal, 1 dimension. Okay, goes on forever. Any questions about a point or a line or how we name them? Good job, everybody. That's vocabulary part 1. Vocabulary part 2 is a plane. A plane is a flat 2-dimensional surface. Okay? A plane is a flat 2-dimensional surface that goes on forever. The best way to explain what a plane is this is a piece of paper. It's 2 dimensions because it's up, down, left, right. If I tilt it sideways, it's supposed to disappear, so make believe that that just disappeared. Okay, it's 2 dimension. What makes this slightly different is a plane in math is supposed to go on forever that way and go on forever that way in all the directions that the plane is in. So the best way to imagine a plane is think of an ocean with no waves, that if you were to look out into the ocean, that ocean goes out forever and ever and ever and ever and ever, and it's perfectly flat. Okay, it's infinite. The way we name a plane is we give it capital letters and we use the word plane in front. So again, this blue object is supposed to represent a plane. I know that that plane goes on forever that way and forever that way and forever that way and forever that way. So it doesn't matter what I name it. I can call it plane B. I can call it plane K. I can call it plane CBDs, DBC, CDB, whatever. As long as I'm adding the points or the name of the plane to it. Okay, now I see there's a lot of conversation in the chat and most of it's useless. So I want to make sure that you guys are understanding what a plane is. A plane is a flat surface. So this is my plane. I'm calling my plane plane N for Nicholas. That's my name. Okay, plane N. In reality, I should demonstrate this plane by taping a bunch of pieces of paper to it so that it looks like this plane is going on forever. By putting a dot and calling that A and putting another dot and calling it B, I have drawn 2 points on plane N. If I wanted to connect those dots, which I'm going to do right now, and put arrows on the end, I just drew line AB on a plane. So I have line AB, and that's what I'm calling it. I'm calling it line AB because I have 2 points on it, A and B, and I'm using the little line above it to call it that. I'm calling this line AB, and it lives on plane N. Or I can call this plane AB or I can call it plane BA because AB and BA live on this paper. All right. So point is 0-dimensional. It's a dot. Line is 1-dimensional. It's just a line. Make sure it has arrowheads on each side. And a plane is a flat surface that goes on forever. Not 3 dimensions, 2 dimensions. Okay. We use the words on the bottom, collinear, to represent points that live on the same line. Okay. Points that live on the same line. So I could say that A and B are collinear. I can't say that A, B, and C are collinear because C doesn't fall on the same line as AB. If I wanted to connect A and B, which is already, never mind. If I wanted to connect A and C, I can say A and C are collinear. But if that's the case, then B is not to A and C. So if I did that, and let me just do that right now. Okay? A and C are now connected. And I'm calling it AC. Or I can call it CA. B is not collinear to AC. AC, A and C are collinear to AC. If I wanted to add another dot, I could say D is collinear to AC, but B is not collinear to AC. Just like D is not collinear to AB and C is not collinear to AB. Any questions on what it means to be collinear? It's literally exactly what it sounds like. 2 things that live on the same line, or it's more than 2 things, frankly. Coplanar is exactly what it sounds like. If you understand collinear, then you can understand coplanar. Coplanar means things that live on the same plane. So let me move up just a teensy bit. A, B, C, and D are coplanar to plane N. if I were to have a dot out here, if my pen represented a dot, so there's my pen, okay, if that pen was point E, okay, and I put it way out here in front of it, okay, so the dot E is way out here in front of this plane. E is not coplanar, okay, because it's not on the same plane. So I guess a better way of making sense of that is if I were to tilt my plane sideways and here's E floating in front of it, E does not live on the same plane as all these guys. Plane N lives sideways in your world right now. And so it's going forever that way and it's going forever that way. This point doesn't live on it. All right, so we talked about a point, which is a dot. We talked about line, which goes that way and that way. We talked about plane, which is a piece of paper that goes on forever. We talked about collinear, which is any point or points that live on the same line. And we talked about coplanar, which is any point that lives on the same plane. If it's not collinear, we use the word non-collinear. Surprise, surprise. And if it's not coplanar, we use the word non-coplanar. Any questions on any of these vocabulary words? In order for you to really understand geometry, you have to wrap your brain around math from a 3D perspective. Okay, if you're good at art, you're going to be really good at this class because you can visualize things from a 3D perspective. If you have a heart, like if you were asked to draw a house 3D, you know that you would make the front of the house much bigger, and as the back of the house works its way backwards on a piece of paper, it appears to get smaller. So many of you can visualize a drawing of a house that's 3D. If you have a hard time with that stuff, it's going to be a little rough. Perspective is the right word. So it's actually a very good word for it. So if you understand visual perspective from the ability to draw a house, and if you're supposed to draw a 3D house on a flat surface, some people are like, I can't do that. Like if I were to ask the class to draw a cube, a lot of you would be able to be like, oh, okay, well, I'm going to draw my square and all these lines going diagonal to represent 3D. If you have a hard time visualizing that, this is going to be a very interesting chapter for you because we do deal a lot with 3D and pretending that dots are floating around in space and stuff like that. It gets kind of iffy. As Takashi once said, he's trash. Use a figure to name each of the following. He is trash, thank you. Use the figure to name each of the following. A plane containing points T and Z. Okay, so this is what we're trying to imagine, and again, bear with me here. Okay, bear with me. We are imagining that this is a picture where it has several lines. I think, oh boy. I think what we're seeing is we're seeing a paper here that's flat. And then we have a line that's going on the paper and another line that's on the paper but also going off the paper. And then the line R goes underneath the paper. Do me a favor, focus more on like off the chat, everybody off the chat, and focus on what I'm trying to explain here because it's very challenging to visualize what's going on. This is N. N is a line going that way. Okay, look for point Y. It's going that way. T is a line that's still on the plane going that way. And then R is a line ripping through the plane going underneath it, which is not part of the plane. If I wanted to label a plane containing points T and Z, the way that I would do that is I would look for the fact that this plane has a P on it, and I can call it plane P. Now you might say, no. T doesn't live on the plane. Remember, the plane goes on forever. So if I wanted to keep this figure going and then color that light blue so that it appears like it's still going on forever, I'm allowed to do that. T lives on plane P, even though visually it looks like T is off of the plane. Planes go on forever. Planes go on forever. Planes go on forever. Planes go on forever. Somebody give me the name of a line containing point T.
TR?
Sure. TR. TRL. I could also call it what?
RT.
RT. I could also call it TX. I could also call it XT. So actually, I feel more comfortable with the X because I'm afraid that R is, I'm not going to go with the R because this picture is weird. I'm afraid that if the T is going this way and then the R is down here, then maybe, although TR is not wrong, because technically if T is way out here, and again, look at the picture, if here's my plane, T is out here. Do we kind of see that? T is right here outside the plane. R is a dot down here. Does that make sense? If I wanted to, if here's T and here's R, I could draw a line connecting the two. It's not on here, but I could if I want to. So we have 4 answers. And 2 of my possible answers are TR or TX or RT or XT. Or I could literally make I can make it VT because I can connect V and T if I wanted to. I can make WT because I connect W and T if I want to. Fun. 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 Intersect. Thank you. What the heck is intersect? The intersection of 2 or more geometric figures is the set of points that they have in common. In other words, they cross over each other. You guys are more familiar with intersecting lines, especially with that first chapter that we did, that if I have a line going that way and a line going that way, they intersect right there where the 2 lines meet. Okay? So that's what intersect means. Do I have anything else on this page? No. Good job by me. So I can have 2 lines intersect. So there's an example of 2 lines intersecting right there. I can draw a plane. So pretend that's a flat sheet of paper. And I can draw a line piercing through it. This would be a lot nicer if I had a whiteboard or a smartboard, but I don't. But try to imagine if I were to take my pen and go like this. And so I stabbed my pencil or my pen through a pencil. This pen intersects the plane at the stabbing point. We'll call it S, at point S for stab. Okay, so the line and the plane intersect. Fun fact, I stabbed my leg just now. I'm bleeding. Oh, it's all right. I don't need it. Draw and label a figure for each relationship 2 planes that do not intersect. If I were given 2 pieces of paper and I were to ask you to hold up 2 pieces of paper so that if those pieces of paper go on forever, how would you hold those up so that they would never intersect? I'm looking for one specific word.
Parallel to each other.
Parallel is correct. Parallel is correct. If I were to hold 2 pieces of paper, here, my stabbing paper and my trash paper, hold them up right next to each other. If these pieces of paper go on forever, they should never intersect. So if I bend them around, they'll never run into each other. So drawing that is going to be fun. So if I asked you to draw that, you would draw yourself a plane like that. So I'm using that trapezoid looking thing to represent a plane. And maybe I'll sneak one behind it or one in front of it. Boy, that looks really bad. But I just want you to pretend like you're drawing. Oh, better yet, here. If I were to draw a cube. No, I know what I'm doing. Look, check this out. If I were to draw a cube, and the way I would draw a cube is by putting a square up front and a square in the back, never connect those squares. Normally, I would put the lines and the diagonals there, but I'm not going to connect them. This shows me that I have a piece of paper living in front of another piece of paper, and those pieces of paper will never intersect. Now, I know you kids are thinking, wow, Mr. Parrish, you're drawing. Well, yes. What time did this class start? How much time do we have?
We have 8 minutes.
Whoa! Draw, okay. Draw and label a figure for each relationship. Points A, B, C, and D are collinear, but A, B, C, D, and F are not. We did start at 11:30. This will probably be the last problem that we do, and we'll wrap up the rest of this lesson tomorrow. Yeah, we're not getting through this today. That's all right. We'll wrap up the rest of the lesson tomorrow morning. No big deal. Since it's a half day, you're synchronous anyway. That means I'm teaching you live anyway. And then you learn about bullying at 9. Points A. Okay, so A is 2. No, you never have homework. A is 2, 3. So I'm going to put A right there. Call you A. So the coordinate plane is your plane because it's a coordinate plane. So you watching what I'm doing, the computer screen, the Chromebook screen is the plane that goes out forever in all directions. So I have B is 2, -3. I'll call you B. C and D are collinear. But A, B, C, D, and F are not. Oh, okay. A, B, C, and D are collinear. That's how I was supposed to read it. Where should I put C if A, B, C, and D are collinear?
Say that one more time.
If I know that C is going to be collinear to A and B, where must I draw my C? You have a little bit of freedom, but it has to be kind of specific. I mean, collinear means if I were to make AB a line, so let me do that quick. Ah! No! Sorry, I accidentally opened up a new tab. If I were to make A and B a line, oh my gosh. If I were to make A and B a line, where must C go?
Quadrant 2.
Okay.
And
Well, this is quadrant 2, but A, B, and C need to be collinear. So C would have to go where specifically? On where? What? Somebody said something and then stopped.
Wait, C has to be collinear to A and
C has
B?
to be collinear to A and B, yep.
Let's put in the middle, right?
Yeah, put it in the middle. Put it anywhere on that line. So
Yeah.
there's C. Who cares? Where could I put D?
Probably under the C or anywhere really, but just
Anywhere really, as long as it's on the line is
Oh,
correct.
yeah.
There's D. Where? Okay. So A, B, C, and D are collinear. So I drew my line and I put A, B, C, and D all on the same line. F is not collinear. Where must I put F? Or where can I put F?
anywhere as long as it's not touching the line.
Exactly right. So I'll put F right there. Okay. So I'm going to end this section right now. My fault spending a lot of time trying to get you guys the notes. We're going to use the same exact notes tomorrow, and obviously we're barely halfway through. But we're going to finish now.